Welcome and good afternoon. Thank you all for joining our Maximize BEAD Success, Harnessing Licensed Fixed Wireless Access to Strengthen Your Offensive and Defensive BEAD Strategies webinar with Intracom Telecom. Here to present from Winncom Technologies, our Fiber Product Manager, Alex Cernik, and Senior Sales Engineer from Intracom Telecom, George Harlaftis. If anyone has any questions throughout the presentation, feel free to add them into the chat and they can be addressed at the end of the webinar. Gentlemen, you may take it from here.
Thank you for the introduction.
All right. Alex, I think our viewers will be mostly interested in learning about the different strategies associated with the BEAD program, defensive, offensive. Would you like to talk about this, and most importantly, how Winncom can assist the customer with the support of these strategies?
Absolutely, George. Thank you. First of all, thank you everyone for taking the time. I believe this is our 7th BEAD webinar in our series. We've got a lot of great information here today, but let me start by saying that over the past 6 months, Winncom has partnered with a pretty diverse range of customers, and that could include WISPs, rural and electric cooperatives, tribes, to bolster their BEAD offensive and defensive strategies. Now, on the defensive front, our customers have engaged in individual state plan service challenges, and now we've assisted them in determining their area eligibility, specifying the necessary parameters for posing service challenges, and providing design assistance. Now, additionally, we've supplied the products needed to fill the gaps in those coverage areas, ensuring they meet BEAD requirements. Our primary strategy has been to eliminate BEAD eligible areas by deploying new infrastructure and using speed tests and other methods to demonstrate that these areas now have sufficient capacity to be considered served. Now, this approach effectively prevents BEAD-sponsored overbuilds by other customers' competitors and ultimately safeguards your market position and your investment. Now, if you're planning on participating in your state's planned service challenge, or a lot of states have upcoming rebuttal programs, please message me through chat or contact me via email to set up a consultation. And at the end of this presentation, we have a lot of the contact information. So if you missed the chat aspect of it, please reach out via email. But ultimately, we can help you identify the rules and the next steps for your states. For our customers' offensive strategies, the process begins with mapping out the proposed expansion area. Now, however, I've noticed that the stage can sometimes be very confusing. Navigating CostQuest, in particular, identifying and downloading the correct files for your state or county, it can be very convoluted. So here at Winncom, we've developed a program that will help to assist, and I'll talk about that in just a minute. So to illustrate, I often say that maximizing your state's eligibility points requires the use of the right tool in a toolbox. Now, Winncom has identified the top eco-center manufacturers that are BEAD certified, whether that's XGS pond solutions, whether it's aerial or burial fiber, or their related installation accessories, whether it's FWA suppliers like Intracom Telecom, who you'll hear from today, or their corresponding supporting infrastructure and networking counterparts. We offer applications and consultative services to help you determine the right solution for you. So let me flip this over here. So additionally, we can help you determine areas of eligibility using our HEX QGIS mapping capabilities. The slide you see here is an example. I chose Upshur County. It's in West Virginia, and they're one of the latest states that just moved through their volume 2s, are in their pre-registration. So in addition to West Virginia, we also have the ability to identify areas in the entire United States. So in the far most left image, you'll see a group of yellow hexagons, and they represent areas that are unserved or underserved. Now, each hexagon is approximately 0.2 square miles. In the second image, I've highlighted a project area that meets the criteria of the 80% rule, meaning they're fully funded. They do not require the 25% grant match contribution. The third image displays existing technologies. Red indicates fiber, green represents CBRS, which could be either a GAA or a PAL license, and blue denotes DSL. The final image on the right-hand side shows previous funding vehicles. And I want to say there's 10 options to choose from, but in this particular example, as you can see in the previous 3 images, the bottom section of that county is black. And it's black for the very reason that it had previous funding with RDOF. So as part of our Winncom value-added service, each hexagon can also be exported into a Google Earth KML file. Now, these hexagons also display the number of locations, the corresponding units, GPS coordinates. You can correlate by cost quest level 8 IDs for checks and balances. And importantly, it gives you the number of houses eligible for BEAD, and that could be below 100 megabits per second. Now, with this planning tool, we can help you easily determine the right technology, the right strategy on how to move forward. So, George, many people might not be aware that Intracom also offers fixed wireless 24/28 gig licensed point-to-multipoint radio systems. Can you explain a bit about that product and how it fits into the BEAD framework?
Absolutely. For those of you who may not be familiar with the Intracom Telecom brand, we are a telecom solutions vendor, and we have been in the market, the wireless market, for over 45 years now. We have multiple subsidiaries globally. I'm talking to you from our subsidiary in Atlanta for the North American market, and we have 3 R&D centers in Europe where we have our production as well. Now, the title of this slide that you see here is FWA 24 and 28. So obviously we're talking about the 2 bands that Intracom Telecom offers the FWA solution. This is through our WISPs product. We're going to talk about it next. But what I want to stress here is the primary markets as far as the architecture and what is it that we are addressing as far as the customer network is concerned. You see the 2 pictures here, the semi-rural as well as the suburban markets. Those are our primary focus. And when it comes down to the actual deployment architecture, the optimal point that you see listed here at the bottom is servicing efficiently an area that covers up to 480 subscribers per base station site. What that means is that if you think about a 360-degree coverage with 4 sectors from that tower up to 480 subscribers, that makes sense. It's the optimal point of the architecture. And a great benefit of the solution is that you can extend this range a little bit beyond 6 miles, as you can see at the bottom. So the extended range where we can offer the high capacities we're going to talk about next for the semi-rural as well as the suburban networks. That's the optimal architecture. Now, what is our approach for FWA? The concept here is, we all know we have a base station talking to multiple CPs or terminal stations as we refer them to. What we think is very important is to future-proof the solution. What we believe is that our customers, when they have to invest, they need to consider that that investment is going to be around and will have long-term performance predictability. That means that for as long as you're transmitting or you have access to the spectrum, you should be able to predict what that performance is going to be in the long run. For us, this automatically means line of sight technology. It also means licensed spectrum where you do not have interference. two very key important features that you see listed here with the on the slide, the bullets at the bottom, is simplicity, because we consider that the simple architecture of a layer 2 coreless network is what really makes sense to deploy cost effectively and provide the long-term performance predictability that we talked about. Now, it really matters to have coexistence with 5G, where of course that is applicable. So we have the different bands 24 and 28. Whatever solution is being offered there for that licensed spectrum, it has to coexist with 5G, and our solution does exactly that.
Now, George, that certainly makes Intracom's FWA solution really compelling. Can you share more information about the radios used in your solution?
Absolutely, Alex. So the particular slide that you see here, 24 and 28, as we said, technology overview. So the concept here is that we have a interference-free networking licensed spectrum solution that starts at 24.25 all the way to 2950 gigahertz. This is the maximum spectrum that the solution covers. It sits a little bit exactly above the unlicensed part of 24 gigahertz. That's where it starts the 24, that you can see how it starts at 24.25 gigahertz. The radios that you see in the middle of the slide, they are the base station as well as the CPE. We're going to look at them in the next slides. But the idea is that we have an advanced Ethernet networking features capability in the radios. That gives us the capability to provide a two-stage hierarchical quality of service. That's the yellow star you see on the second tab at the top. So quality of service is a major thing that we're offering through our FWA product. The next tab underneath that, you see the high performance. This is a TDD, as the parentheses mentions, TDD architecture, not to be confused with FDD. And you can see that it says that up to 5 gigabits capacity per sector. What we mean by that is the aggregate capacity of the sector that includes both the downlink capacity as well as the uplink. So the variants that we offer, it can take the aggregate capacity all the way to 5 gigabits. The platform can deliver hitless adaptive modulation, as you can see, up to 1024 QAM. At the very bottom, you see on the left side, the long-range links with a yellow star associated with it. That's an extremely powerful advantage that the system offers for up to 6 miles service delivery. And as you can see in the parentheses, we can deliver 1 gigabit all the way up to around 2 miles there. On the top right, you see the high subscriber density of up to 100 TS. That stands for terminal stations, or CPs per sector. So we use the term interchangeably, whether TS or CP. Now, the architecture of the radios itself, you can see that it is a compact all outdoor units. We also have very well optimized network deployment features with integrated planning, capacity analysis tools, zero touch provisioning, automated procedures to help you with the auto authentication, auto provisioning, and all of these are covered by the life cycle management system that we have called UniMS, a very powerful centralized management platform that helps you cover any of your needs throughout this product life cycle, as we call it, whether it's in the beginning phases where you plan your network, the actual implementation and installation, even later on during the maintenance. Let's talk a little bit about the frequency of operation associated with the 24 and 28. The top tab that you see there, that's the frequency range of the platform. And there are two split ratios, the 4:1 and the 3/2. Channel sizes, 40, 50, 100, as well as 200 megahertz. There are 3 main supported subbands, and you see them mentioned as lower, mid, as well as the upper. The lower that you see is the 24250 that we mentioned, all the way to 2650 gigahertz, and that is associated basically with a 24 gigahertz here in the US. The bottom one that is actually designated as upper with respect to the frequency, that starts at 27,500 to 29,500, and that represents the 28 gigahertz assignment. This particular subband, you can see at the bottom at the sketch there, at the graph, where it shows the system capabilities, as well as the yellow box, the LMDS bands, the LMDS band that represents 850 megahertz split into what we used to call the LMDS L1 as well as L2. So L1, 425 megahertz, L2, another 425, covering the what used to be used as the term for LMDS. Now, the base station variants, again, this is a TDD system. There are two variants that you see. The one on the left, 2425 all the way to 2950 capabilities for gigahertz. It is an FCC certified, obviously, solution. It supports 40, 50, as well as 100 megahertz channels, and you can see the aggregate capacity of 800 megabits. Again, this is aggregate capacity, including the downlink as well as the uplink. So if we want to think in terms of an average, maximum, we're talking about, at least in layer one, roughly about 700 megabits for the downlink and 100 for the uplink. That particular system is the WISPs G5 EvoBS, again, aggregate capacity up to 800 megabits. The system on the right, this is the newer system that we are deploying. This one starts at 26.5 all the way to 28.5 gigahertz. This is a MIMO solution, beamforming, and the difference in the channels, as you can see, it supports 100 and as well as 200 megahertz channels. So if you want to switch to the 200, and by the way, this is the one that gives the capability of 5 gigabits aggregate capacity. That's the system. It's called the WISPs G5 Smart BS, and this is how we deliver the 1 gigabit capacity. Let's look at the terminal station now, as well as or what we call what we can refer to as the CPE, and the left system, that is the WISPs G5 Connect Plus. It same band coverage as the base station EvoBS we saw in the previous slide. Again, 800 megabits capacity, same channels as the EvoBS base station, 40, 50, and 100. And this basically shows that if you want to deliver the entire capacity towards one CPE or terminal station, you can do that. Again, roughly about 700 layer one downlink and 100 on the uplink. The system to the right, that is the, again, CPE or terminal station called Giga Connect. And this is the one that we can deliver the 1 gigabit service. And again, supports, just like the Smart BS that we mentioned in the previous slide, 100 as well as 200 megahertz channels. There's a very important reference that the whole WISPs platform has, and you're looking at it. This is Eolo in Italy. This is one of our customers that helped us build the largest millimeter wave FWA network in the world. This particular one has is with 28 gigahertz spectrum, and you can see the pictures of the CPEs that we have deployed there. We have exceeded the 250,000 CPEs deployed with this customer, again in Italy. It's the world's largest millimeter wave FWA network worldwide. Next slide, please. Okay, when it comes down to the entire worldwide reference that we have that shows that this is a very reliable solution, what we can say is that we have built more than 50 networks worldwide. Base stations, we have exceeded 18,000. And as far as the CPEs or terminals, more than 500,000 already out there. As you can understand, this is something that has evolved through the years, actually more than 20 years. And that's how we have accumulated expertise and know-how on the FWA. I think at this point, that's what I have to talk about as far as the product is concerned. But I think we need to provide our viewers with some options when they do not have access to the spectrum. Alex, would you like to talk about that? What kind of options are there if our customers do not have access to the spectrum? What can they do in this case?
Sure, absolutely. So I think first we should start with understanding the spectrum. So in 2019, the Federal Communication Commission selected 29 winning bids who participated in auction 102, and that was for the 24 gigahertz frequency. Now, in that same year, the FCC auctioned off another 3,000 licenses for the upper microwave flexible use service. And for those of you who are great with acronyms, that's the UMFUS band. Now, this was known as auction 101, and that was for 28 gigs. So a lot of the spectrum has since been unused, and it's honestly laid dormant. So the benefit of using licensed point-to-multipoint is higher availability capacities, along with that safeguard against interference. So partnering with Select Spectrum, we provide a matchmaking service, for a lack of the better term, by aligning your state and your county build-out plans. We can assist in identifying spectrum eligibility and navigating the license process post-purchase. Now, the map you're seeing here illustrates available spectrum in both 24 and 28 gig bands. As you can see, there are a lot of areas of opportunity. Now, if you're interested in this frequency and this technology, please request assistance. And again, the best way of doing that is through either the comment section or by emailing myself or George at the end of this presentation. So George, we've discussed how licensed point-to-multipoint can benefit customers applying to BEAD. How can 80 gig E-band complement FWA and last mile fiber deployments?
Yeah, sure. So what we have talked so far is the FWA, which is a basic concept of a base station talking to multiple points. That's the architecture of point-to-multipoint. Obviously, when you have all this traffic that is being consumed at the CPE side, then you eventually concentrate that at the base station. You need to backhaul that, right? And fiber, of course, is a very, very common solution, but there's a lot of solutions out there that require wireless interface because wireless connectivity, because fiber may not be readily available, or it will perhaps it will not make financial sense to deploy it there. Now, microwave links are, for the most part, a very common solution for this case for the wireless point-to-point connectivity to backhaul the traffic. But what we have noticed is that there's a very high utilization rates in existing microwave links with perhaps little space left for growth. Now, the side effect of that is, as far as the service is concerned, is that there's reduced or downtime on services during peak demand. What we have also noticed worldwide is a trend with the regulators. Because of that scarcity of spectrum, there's a push for increased efficiency, and sometimes they're pushing for XPIC implementations. In this kind of situation, in this environment, E-band became a very popular solution because of basically its cost effectiveness, because it's a likely licensed solution. You don't have to purchase the spectrum, but just like in the microwave scenario, but you just register it. And it is a great solution because it has a lot of bandwidth. You can go up to 2,000 megahertz channels, and very cost effective. You don't have to purchase it. However, it has some disadvantages when it's compared to microwave because of the physics, right? It's a higher band. It doesn't perform very well sometimes during weather anomalies. And that's why there's a lot of consideration for the inner working with microwave. But either way, the bottom line is that this is a very effective solution to consider for backhauling high capacity traffic cost effectively. And when it comes down to the backhauling with E-band, what really drives the solution, the effectiveness of the solution, is the system gain. So when you consider E-band links, you have to consider something that will be stable out there. And the answer to questions like that for stability is the system gain. Intracom Telecom's GX80, Ultralink GX80 10 gigabit radio has the highest system gain in the market. And it is a fundamental driver of this solution. We're going to show you the next slide here. There it is. So that 70.6 dB at 10 gigabits that you see on the right, that is the Ultralink GX80's 10 gigabit radio by Intracom Telecom. That's our system gain. Now, again, this is the highest system gain in the market at 10 gigabits. And some of you may think, okay, so what does that mean? Sounds like a great feature, but what are the advantages? There's many advantages, OpEx related as well as CapEx. The primary one is that you can have longer link distances, right? And we have references where we have proven that we can go even beyond 8 miles and have that link transmit and sync very stably. Now, there's also a lot of other advantages, such as the robustness during the weather anomalies. As I said, E-band may not perform in the same way as microwave, but when you have that highest system gain, that capacity is going to be a lot more stable, and it's not going to drop as rapidly compared to a radio that doesn't have the same or has lower system gain. So you'll switch from higher modulation to a lower modulation much more rapidly. Of course, the system gain will help you with the total link reliability as well. So that link is going to stay active a lot longer. But there's other advantages as well on the CapEx side. So when you compare two links that have one being the highest system gain and another one with less system gain, what you could be installing on the radio that has the lower system gain with, let's say, a 2-footer antenna, perhaps with the such as the Ultralink GX80, since it has the highest system gain in the market, you could be doing the same thing. You could have the same performance with, let's say, 1-foot antennas. So that automatically means that you have the same kind of performance for a smaller antenna, which translates in a lot of cases with smaller rental space on the tower. That's a significant cost for a lot of companies out there. And once you have a smaller antenna, you may have a lot of reduced time on the alignment, because that lobe is going to be a broader one compared to, let's say, the 2-foot antenna. So it's going to help you out with the alignment as well. Particularly recently, the FCC approved the smaller 20 centimeter. You can use 20 centimeter antennas with a specific gain that they approved. So that plays a fundamental role in a lot of savings there for our customers. To say the last thing I wanted to mention is, once you have a smaller antenna, you can have better stability on the poles, and that affects the entire operation of the link. I'd like to mention a few things about this particular radio, the Ultralink GX80 10 gigabit system that we have. The picture on the right at the top shows you the antenna, how it interfaces with the radio. The bottom picture shows the different ports. It's obviously an embedded switch, and it's got an embedded switch, so you can see the multiple ports there for the gigabit interfaces. And what I also want to mention is that this is a system that supports multiple channels, 1500 all the way up to 2000, as you can see at the top. Different configurations from 1+0, XBIC, RLA, dual band. You see them mentioning their dual band with, at the third bullet, with Intracom Telecom radio. That's because we're transitioning our microwave portfolio. We also have microwave portfolio that we are trying to bring into the North American market, and we're transitioning that currently. So you can do dual band with our microwave radio as well as third-party microwaves, microwave radios, as the bullet point mentions there. The modulation scheme starts from 4 QAM and can go all the way up to 1024. The important part of this slide is the red circle that you see there, where it exceeds 70 dB system gain. That's what we talked about earlier, the highest system gain in the market. I also want to bring mention the fact that this radio is IP/MPLS ready, so it can support layer 3 services if our customers are interested in doing that. Ethernet networking functionality, OEM, as you can see in the bullets under that, quality of service, advanced packet synchronization, even CPRI actually, as well as eCPRI.
No, I like that, George. So, I mean, simplifying this, if you're looking at application-wise, this could be used for last mile fiber. This could be used as a high capacity backhaul for fixed wireless access technologies like, as you said here, 2428, but also CBRS, which is also readily deployed. And then I like the aspect of the dual band being agnostic. And if they've got infrastructure that's 18 or 23 gig and it's either single core or dual core, you can take a 400 or a gigabit system and convert it to 10 gigabits per second with that licensed radio being redundant when you've got those atmospheric weather phenomenons. So that's amazing amount of information. Thank you.
Yeah, sure. There's another slide that next that we maybe, there you go. Yeah, that's perfect timing actually, Alex, for what you just said. Particularly for the BEAD program, the existing infrastructure can be extremely useful for a customer to basically upgrade their capacity using the dual band concept, as you mentioned. So the idea of reusing the microwave links that may be existing in a customer's network is extremely important, because with this BEAD program, they can actually increase that capacity. Let's say if that was if that is let's say up to 1 gigabit because of the smaller channels that microwave links use, we can actually show how we can increase that capacity all the way up to 10 gigabits. There are two ways, as we said, the brownfield part, the icon there on the left, that shows how there are two separate links on a tower. So you start off with the existing microwave link. You don't have to dismantle your antennas. Then you place in parallel the E-band link, the Ultralink GX80. Again, that's the system that has the highest system gain in the market at 10 gigabits. So you don't dismantle the antennas. You use your existing antennas and you place the Ultralink GX80 in parallel. Now, if you want, you can also use the concept you see on the right under Greenfield, and you don't necessarily have to have two antennas. You can actually put both radios, the Ultralink GX80 E-band radio, as well as the third-party microwave that you may have in your network, and you can attach them both on a single dual-band antenna. The parentheses there for the flange cassette is to basically designate the fact that we're having to custom build the interface between the third-party radio and our antenna, but they can both fit into a single dual band antenna. Now, the picture on the right, it shows you how the two units interface when they're in the brownfield approach, that you have the two parallel links. You don't dismantle your existing microwave antenna. The one at the top is the Ultralink GX80, the 10 gigabit radio. So that sits on top of your existing microwave radio, right? And what I need to mention here is, because of that highest system gain in the market, we have references where we made the 10 gigabit run stably at even beyond 8 miles. So what that means is that effectively, if you have, regardless of whether you're implementing an FWA approach with Intracom Telecom, you can still consider a major advantage that you have for any link, any microwave link that may be having issues with capacity upgrade due to lack of spectrum. You can actually take those links that are all the way up to 8 or 9 miles and upgrade them with Intracom Telecom's UltraLink GX80 up to 10 gigabits. And we have multiple ways that we can interface with a third-party microwave, whether it's standard or non-standard, but we can basically make sure that you don't lose any of your priority traffic when there is weather anomalies. So when the E-band does not perform very well, as we said earlier, you can still reroute traffic through the microwave and keep all of your priority traffic. But think about it. If you just want to upgrade, if you have an existing link up to 1 gigabit, you can actually consider a very, very cost-effective solution to upgrade that 1 gigabit that you have existing with your microwave without purchasing any spectrum. You can increase that capacity up to 10 gigabits by inserting that UltraLink GX80 in parallel. So that's a great advantage. We can make it work with multiple ways how the two units can talk to one another, but all the way up to 9 miles, you can increase that capacity. And there's a lot of room when it comes down to availability. Perhaps you don't need to have those 3 or 4 nines for the extra capacity beyond the microwave. Maybe you can say, hey, it's okay to have less availability as long as I get this upgraded capacity with much less, with a very cost-effective solution such as E-band.
Excellent.
I think that covers the product for the point-to-point as well. I think at this point, what we need to do is to complete the circle. I think we need to talk about the services that Winncom can offer for the BEAD program. What do you think?
Yeah, I think that's a great segment. Thank you.
Okay.
So thank you, George, for going over the product. I think that made a lot of sense, and I think that makes sense to a lot of the customers that are probably on this line. Before I get into services, first let me start by saying Winncom is a value-added distributor, and for nearly 30 years, we've been specializing in providing eco-center solutions with comprehensive engineering and technical support. Our offering includes BABA certified products that support both active and passive fiber, along with their associated accessories. We also provide BEAD waiver approved electrical products and complete infrastructure and networking solutions. Our goal is simple. It's to bring you the industry's leading manufacturers like George from Intracom Telecom today, while assisting you in the vendor selection process with a consultative service and product design support. Now, with that in mind, the second part of our strategy focuses on enhanced services. To streamline your experience, we provide a single point of contact throughout your entire BEAD submission process, backed by a team of experienced BEAD experts and engineers. Your Winncom account manager will serve as your liaison, guiding you through our grant writing service, professional engineering, and financial support programs. And I'll dive into each one of these programs in the upcoming slides. Now, through our grant writing services, we collaborate with your engineers to design your project and devise a strategic plan. Now, starting with a high-level design, we develop a comprehensive project budget outlining all the necessary components for implementation. Now, this encompasses the executive summaries, the project and the budget narratives, the budget spreadsheets, gathering all that financial information, and facilitating a digital application submission. Now, additionally, we can provide post-award compliance services, which include consulting, performance reporting, invoice reimbursements, and closeout reporting. What this slide showcases is an overall timeline. And what I would stress here is a sense of urgency. Right now, there are 6 states that are moving into the pre-registration phase. And as you can see here, for a standard minimal time, it takes anywhere between 6 to 8 weeks to kind of process an entire grant application through our grant writing services. And to kind of extrapolate what that timeline looks like, once we gather the information, and I have a slide, it's the next slide that talks about how we do that, but that could be anywhere to 3 to 5 business days for onboarding. The crux of where the time is how much information has to be collected versus stuff you already have. So it could be anywhere between 2 weeks if you have everything already baked. But if we need to work on design and engineering and pulling together financials and working with your CAPA forms or internal accountants, it could be anywhere from 6 weeks. All that information is then curated, entered into the application. There's a checks and balances process built into this. So there's a 1 to 2 week review period. The team we're working with are experts in your state. So depending on your state, we have an experienced representative who kind of works with us on that QA process. And then 1 to 3 days on application submission, where we'll answer any questions that come up. And then we offer a post-award compliancy part just to make sure money doesn't get clawed back. What we're showcasing on this slide, this is our grant writing checklist. So Louisiana was the first ones to supply an ISP plan. I believe it was like 6 pages. And if I use the word convoluted, I would be nice about it. But it was a lot of information, not very well formatted. So again, everything we're doing here is streamlining and trying to simplify a fairly complex process. So with our grant writing checklist, we took all of those questions and we put them in more logical format. What's the project scope? What's the corresponding service area? What's your business plan and operational plan? So if you're ready to move forward with a grant writing process, again, reach out, request this checklist. We can walk through it with you. And then upon your completion, again, the previous slide went through what the timing looked like. But again, I do want to stress time is of the essence, with most states are kind of moving into that pre-registration. The other thing we offer with this turnkey solution is professional engineering. Now, that could encompass several things. If we're talking fiber optics or XGS-PON type solutions, we can put boots on the ground in all 50 states. We can offer high-level and low-level design services, but ultimately this gives us a force multiplier. We have up to 115 design engineers, 50 plus pole technicians, 75 plus project managers, but ultimately we can help design your solution for these grant applications. We also have the ability to go on site, do site analysis on the wireless side, do GIS mapping on the wireless side. But as you'll see in this slide, one of the requirements for every one of these grants are PE stamp drawings. So the 3 SKUs you see before you can do or serve as one of 2 things. It can be, if you have most of this put together, we can run this through as our checks and balances. If you're starting off with a new system, we can, from scratch, put this together, and our deliverable will be giving you a PE stamp drawing, which again is part of that eligibility requirement on these grant writing services. Now, we bring this all full circle with our LEAF financial partner. And what I mean by that is one of the things we're trying to do is provide you with a lever, so to speak. So grant writing, professional engineering, there's cost associated to that. So that's not reimbursed by the initial bid or grant, so to speak. With LEAF, instead of having that CapEx hit all up front, you can carry that over a 3-year period. So again, helps you manage your cash flow. There's also a match requirement of 25% on most of these links, but that 25% gets reduced for prepayment. So again, using that analogy of a lever, we can lease this over a 5-year period of time, and that gives you the ability to get to control that CapEx expenditure and your cash flow. Now, we bring this all into play with our BEAD portal. I will provide a link. I think it's our second to last slide. It's simple to join. You put in your email address and you make up a password, and this gives you access to things like these webinars. As I mentioned, this is our 7th webinar in the series. We've got a series here if you wanted to see WISP-friendly fiber, aerial versus burial, and how that relates to BEAD, or if you wanted to see for Kansas or West Virginia, what each state's timelines look like, what their scoring requirements look like, and what the next steps would look like. Again, as states are moving to pre-registration, we're going into detail about what each one of these steps entails. Our supplier and product section gives a detailed breakout of what vendors are BABA certified, or under the FWA products, what products meet the waiver wire or the unavailability waiver of eligibility. And then we have an aspect here under state funding for each one of the states, how much money is allocated to it. And then we set what that timeline looks like. Again, we want to make sure that when you're ready to move forward, you've got enough time to get all these pieces of the pie in place. And again, this is a fantastic resource to leverage. And that's, again, part of our value-added service as your distributor. So if I had to set some recommended action items, I'd say reach out. You can see some email addresses here, bead@winncom.com. If you're planning on moving forward, if you're in my offensive or defensive stage, do I need help with mapping? Do I have mapping already completed and I need help with a grant writing application? Is professional engineering or PE stamp drawings? Do you have questions about what vendors are certified? Reach out to me. We can certainly sit down, talk about your individual state, what those guidelines look like, scoring requirements, technology requirements, to make sure you're in the best case scenario to win these grants. If you want to hear more about the program as well, reach out. Or if you want to schedule a call to learn more about Intracom Telecom for your BEAD applications, or if you've got immediate opportunities, please leverage this opportunity as well. And I've listed George's email at the bottom of this. And the last aspect here is that BEAD portal, winccomus.com/BEAD/. So the last thing I would say, and then we can open this up to questions, is now, but Intracom has a really aggressive promotion. As George mentioned, they have the highest system gain in the industry, which did correlate to further distances, better reliability, more adaptability in regards to weather conditions, and then that dual band aspect, giving you the ability to go up to 9 miles, is significant. So if you've got immediate opportunities, reach out to your Winncom account manager, reach out to George or myself, and we can certainly help you with a design, a bill of materials, and assist in any way possible. George, did you want to comment any about this?
Yeah, I think that's, as we said earlier, this is a great opportunity to associate the solution that Intracom Telecom offers with a BEAD program. If you want to increase that capacity of any links out there all the way up to 8 or 9 miles, this is the perfect radio that can do that by basically upgrading the capacity of that existing microwave link all the way to 10 gigabits. This is the radio because of that highest system gain in the market at 10 gigabits.
Excellent. So we'll open this to questions.
Hey, Alex. So we have 2 questions to ask. The first one, actually, we have 3. The first one, can Intracom provide path loss files for us Winncom engineers?
That's a great question. George, did you want to take that or you want me to?
Yes, absolutely. For the Winncom engineers, yes, we can do that. That's not a problem. Just we'll take it offline, contact me, and we'll take care of you. Not a problem.
Perfect. I have 18 and 23 gigahertz links in my network. Can the GX80 radio work with them for the capacity upgrade?
Absolutely. So the whole idea here is that we are providing an agnostic when it comes down to the radio, the third-party microwave. it's agnostic to what the radio is. All we need is just a single gigabit interface so that we can talk to the third-party microwave radio. Just reach out if interested, and send us the specs of the third-party microwave. We'll check it. We'll see the implementation, it's standardized or not. We'll check the standards, and one way or another, we'll make it work. It's not a problem. And again, just send us the specs. We'll look at it, and if it's something on the interfacing that is not standardized, we may require a little bit of an IoT there, but we'll make it work one way or another. We'll upgrade that capacity for you to 10 gigabits all the way up to 8 or 9 miles. We'll talk about the case, figure out the success criteria together. We'll check analyze the RF plan, and we'll make it work.
Perfect. Okay, well, I have one more question for you, gentlemen. How do I find out my state's timeline, technology preferences, and scoring criteria?
I was really hoped that was going to be true or false question, but let me try to take that. So as I mentioned a couple times, I would reach out. It can be through the chat. It can be through the email address. I'll kind of move back to that here. Or not. Hold on, from current slide. Here we go. Through the email address here. So each state's a little bit different, and they have different timelines. They have different technology requirements. They have different scoring criterias, but we do have a list of all that. So again, either reach out through bead@winncom.com, send a message through chat, but ultimately I'd like to sit down with you, and we can certainly walk through the timelines and technology preferences. I'd like to get a sense of where you are in this process. If you've started the offensive strategy, if you've done planned service challenges, there's concerns of people overbuilding in your network, if you've done any of the mapping or downloading the cost quest information. So again, give us an idea of where you are in that process. So not only can we be informative in regards to what's happening in your state, but we can help set up what those next steps would look like and set the right expectations. A great question, thank you.
Wonderful. Well, thank you, George and Alex. This has been great. As a quick reminder to everyone else, we will be providing a copy of the slide presentation and the video when the upload is complete. So please keep an eye out in your inbox for those, as well as a link for all to take advantage of the current Intracom Telecom promotion. So I hope you all have a wonderful rest of the day. And as always, thank you for joining.